In part 1 of chapter 18, we discussed how we can start with benzene and in one step transform it into a benzene derivative, bromobenzene, alkyl benzene, acyl benzene, etc. Now, we would like to know how to change the substituents, the alkyl substituents on benzene into other substituents. So we're doing now the transformations of the substituents on benzene. Now, I'll grant you this. A lot of this comes from organic 1. So you may have difficulty remembering all of those reactions. We will focus on a few, mainly the Sn2 reactions, and perhaps in the chapters that follow, 20 and beyond, we can recall some of those reactions that involved alcohols, alkenes, alkynes, etc. But for now, let's actually look at some basic reactions. So if we look here, it says reactions of alkyl substituents on benzene, and the alkyl substituents on benzene can be converted into many other functional groups using reactions that we have already talked about, of course, including organic 1. Now, the most important one that I need you to remember, and this is a new one, is this one right here, is where we go from an alkyl substituent to an alkyl halide. So here, for example, you have methyl group, alkyl group. We were able, using NBS, peroxide, and light. NBS stands for a specific compound. All you have to remember is NBS. We were able to add the bromine as a replacement for one of the hydrogens. And then once we do this, we have so many options. For example, look how once you have the bromo group attached, look how you can take it to an alkyne. And then, of course, if you recall from organic 1, you were able to go from an alkyne to, in this case, a ketone or an aldehyde. You had to use specific reactions for those. And then, of course, you can go from a bromo, the alkyl bromide here to an alcohol. And, of course, go to an aldehyde, to a nitrile group, azide, etc. So let's look at an example here. So for example, you may have ethyl benzene to start with. And if you're given NBS, peroxide, and light, this is a radical reaction. You may be able to transform this and I'm going to attach the bromine right there as this compound where now you have an alkyl bromide. So make sure you add your bromide to that carbon where the benzene is attached. And then when we get to this point, we may be able to do plenty of reactions as I just described to you. So look how useful this reaction is. All we have to do now is, for example, use NaOH. And if we do that, we can now turn this reaction into an alcohol. I meant the intermediate here, or in the intermediate step, into an alcohol. So you were able to go from an alkyl benzene to an alcohol overall. If you don't remember what this is that although you could have an elimination as well, there's an attack here where the bromine is actually kicked out. This is more of an Sn2 reaction. Could be an elimination reaction as well. You also, again, could have used NaCN, like what's happening here, where now you're replacing so you're creating a nitrile, so on and so forth. So it is very possible to come up with many, many reactions. Now the next, so for now, all I need you to be able to do is do this reaction and be able to do simple Sn2 substitution reactions, where basically what comes after that step is the replacement of the bromine. It's a leaving group, if you recall, from organic 1. With the nucleophile. So be able to do basic Sn2 reactions. They were really, really come in handy. So very well. The next reaction we need to discuss is oxidation and oxidation reaction. And we did cover that in organic 1. In organic 1, we talked about the idea of using a potassium permanganate or some kind of a dichromate. In this case right here, this is dichromate, sodium dichromate reagent to oxidize the, in this case, last semester we talked about the alkenes, oxidize alkenes. So this semester we can do that with the following. All you have to know is if you have all of these, potassium permanganate, heat, sodium hydroxide, water, and then followed by an acid, that's the second step, is what you can produce for all three of these, and there's a key about all of these, is that for all three of these, you can turn them into benzoic acid. Well, sorry about that. Let me just go back. Or sometimes just written as CO2H. So you are able to turn all of these alkyl substituents into benzoic acid, which is, by the way, a preservative in canned food. So, however, there's one thing you need to be careful about, is that when you apply this reaction to a tertiary, in this case, actually this is quaternary, meaning it has 4 carbons attached to it, you will get no reaction. And there's a reason for that. Each one of these that I will put a star next to it, they have an H attached to it. This one, if we were to draw out, it would look like this. It's this tert butyl. So there are no what we call benzylic H's. So all, in this case, all of these have benzylic H's. Now, of course, what is a benzylic H? So here it is. I'm explaining it to you. So this is benzene. So let's actually expand this so we could show you this. When benzene is attached to another carbon, this whole group is called benzyl. So by benzylic hydrogens, we're talking about these. So they're the hydrogens that are attached to that carbon, that first carbon on the benzene ring. So those are called benzylic H's, and you must have them. If you look down here, this is tert-butyl. It has no benzylic H's on it, so the reaction does not take place. That's what the oxidation process yields. Very well.